Okay, we're recording now, and we're on the first slide of the System of Linear Inequalities lesson in Desmos, and we need to put a point so that it'll be in the solution of this inequality. And so we've been working on that for a few seconds. If you are unsure where to put it, it needs to be in this blue section somewhere. Put your point in the blue section. You can put tons of points, like you can put more than 1 point. It'll graph all kinds of points for you. So I'm gonna put mine in a super easy one to graph. How about the origin, 0, 0? That's in the blue part, so that would be a solution. And there's tons of answers for this. That's the nice thing about these inequalities, is that your answer might be different from mine, but they both might be correct, because as long as it's in the blue shaded region, you're good to go. So I could choose another point and maybe like -8, -3. And that one's way over here. That's deep into the blue section. That would also be a solution to this inequality. There's tons of them, all the points that you could possibly think of in this area. And that's not even all of them. Like if you zoom out, there's more and more and more and more and more possibilities. There's like an endless number of possibilities. The only stipulation is that it cannot be in the white part. If you plug points from the white part into the equation, it won't work. So like I had, let's like go a little bit closer here so the numbers are not gigantic. I think originally I had 6, 4. So I'm gonna plug that. So 6, 4, okay? So 6, 4 is right here in the white part. If I chose that one and I plugged the 6 in for the X and the 4 in for the Y, let's see what would happen with that. So it would be 4 times 6 plus 3 times 4, like that. So do you see how in the little, after I like finish putting the 4 in the little gray box, it says equals 36. So that means that this is what this expression equals. Well, this expression is supposed to be less than 12. And so see how 36 is definitely not less than 12? That's why that point, 6, 4, is not a solution. That's why we can't pick that point in the white part, because all those points are going to make numbers that are going to be bigger than 12. And we have to have our answer be less than 12. So algebraically, that's why that's like that. All right, so let's move on to the next slide. Everybody move to slide 2. All righty, now in this one, we're doing the same thing. So notice there's a slight difference between the color. The color is obviously different, but in slide number 1, see how we had a dashed line? So that means you can't put your point on that line. If it's dashed, then the solution is not on that line. But look at slide number 2. In slide 2, we have a solid line. So you have to have really good eyes when you're looking at all these graphs. So your solution has to be in the shaded region, but for this one, it could actually be on the line. So let's see, this point right here, 3, 0. That's a solution. That is A-okay. Go ahead and type some points on your slide that would also be solutions to this. I'll put a couple more on mine too. Good job. Good job. Gloria, Dana, Albert, David, Gaspard, Maria, Simon. Awesome. All good. Good job, everybody. All right, so that's the idea for that. You have to make sure that the points are in the shaded region, or in this case, they're allowed to be on the solid line. Excellent. Let's move to slide 3. Now, this one has both the lines on the graph. This is called a system of inequalities. The other ones that we were looking at were just called inequalities, but this is now a system because you have more than one graph. You've got the blue and the red on one coordinate axis. So do you think there is an ordered pair? Do you think there's a point that would be a solution to both? And say yes or no, and then also tell me why you think that. Got to put my mask back on. For those of you that just joined the meeting, like you joined the meeting after I started talking, here at school, we have to wear our masks all the time now. So that's why I'm talking to you through a covering. Kind of funny looking. Hopefully you can understand me. I'm trying to like talk as clearly as possible. Nice job. Yeah. Good. So a lot of you are giving me some nice answers, some nice explanations. Don't worry about it being like perfect grammar or anything. No judgment here. I'm definitely not the grammar police, that's for sure. It's definitely a more complex graph, but yeah, yes, they do. Good. All right, so nice job, everybody. So the answer is yes. So if you said yes, you are correct. There are actually more than one ordered pair that is the solution to this. Okay, so the ordered pairs need to be in the shaded region of both graphs. So there's my response, okay? And a lot of you said the same thing, very good. So the shaded region for both graphs is in this area right here, okay? I was kind of hoping that that would turn a pretty shade of purple, but unfortunately, Desmos it's kind of, I guess if you like imagine it being purple, I was just really hoping it would turn purple. But it's where both graphs, where their shaded regions overlap each other. So your solutions are all down here. Now, this spot right here, that's really tempting to say that that's a solution, but for this problem, it actually isn't. And because this is dashed. If that was a solid line, you'd be fine. But since this blue line is dashed, I can't actually count that point right there as a solution to this problem. Okay, nice job, everybody. Move to slide 4. Go ahead and type an answer in the box. right. Good. Very good. So write 2 ordered pairs. You need 2 answers. So your answers have to be where both of the shaded regions overlap. Both of the shaded regions have to overlap. So they have to be down here. So you cannot answer with something up here in the blue because that only satisfies one of the inequalities. And you can't answer over here in the just red part. So you might need to change your answers if you chose something in the blue, just the blue, or just the red. It's got to be down here, guys, okay? Has to be where they both overlap. So a possibility could be, I'm going to steal some of y'all's answers. Albert's got a good one there. 0, -2. That's a good answer. And then I am going to steal, who else do I see has a good answer? Gloria, she's got a good answer. 3, -3. That's a good one. 3, -3. So 0, -2 is right there. 3, -3 would be over 3 and down 3, which actually is going to be way down here. But that would be an answer. It's just we can't see it right now. But that would be an answer. If we just counted 3 blocks, that would be like 1.5 for this because we're going by 2s. So, but still it's correct. Okay, nice. Move to slide 5. This is a good one to ask. We talked about this. I just said something about this a few minutes ago. So is 3, 0 a solution to this system? Go ahead and type your answer. All right, I see some answers popping up. Albert, you're a little outnumbered, I think. But guess what? You're right. So Albert said no, and Albert is completely correct. You're the only one that said no. Oh, Simon's saying no. So the reason that's a no is because the blue line is dashed. Remember, I just said that like a little while ago. Maybe you were concentrating on your graph while I was talking about that. But 3 zeros right here, guys. This is the point 30. And so if that blue line was solid, you'd be okay. But it's not. So that means that we can't count that point, okay? Since 3, 0 is on the dashed line, it is not a solution, okay? All right, nice job. Those of you that said no. Very good, Albert, leading the pack. All right, let's move to the next graph. Well, not the next graph, the next slide. So this one's one where I just kind of have to give you some notes, okay? So if you don't have a graph, describe a second way that you could confirm whether or not an ordered pair is a solution. So I did this a few slides back, way in the beginning. I think it was way back on slide 1. You don't have to go back to slide 1, just look at mine. So remember when I had that 0.6, 4, and I was trying to prove that it was not an answer? what you do is you plug in the X value for the X up in the equation, and you plug the Y value of the point in for Y and see if it gives you a true expression. So if you don't have a graph, what you would do is take the ordered pair that is given and plug, plug the X value in for X in the inequality, and the Y value in for Y. See if it makes a true statement. Okay? So you do this a lot. Like you may have done this when you take some of your tests and like you're not sure how to solve the problem. So you just take the multiple choice answers and plug them in for X or plug them in for Y or whatever the variable is. That's what you're doing here. You're just taking the ordered pair and plugging the X coordinate in for X and the Y coordinate for Y and seeing if it actually works, if it is a true statement. All right. Nice, good. Make sure that you type something similar to this in for your slides, because all of these Desmos activities, you have them forever. They don't go away. So when you sign back into Desmos, let's say you take like Algebra 2 in like a year or so, or even geometry, when you sign back into your Desmos, you're gonna have all of these activities still underneath your name. So you can look back at them if you need to look up stuff. So they kind of serve as your notes. So type something on every slide. Alrighty, let's go to slide 7. It says, I guess it's not telling us, I guess it's just telling us to move on, isn't it? So let's go ahead and move to slide 8. All right, so of course, we have to sneak a word problem in here somewhere, right? So that way we can apply this to something in real life. So let's read this together. It says, the student council is selling tickets to the winter dance. Tickets cost $5 per person or $8 per couple. To cover expenses, at least $1,200 worth of tickets must be sold. No more than 500 students can fit in the gym where the dance is being held. So we need to create a system of equations, okay? One of them is going to be about money, like how much money, the $1,200, that's going to be the money inequality. The other inequality is going to be about how many students can go to the dance. You can't have more than 500 people in the gym. So we're going to use that for our second inequality. So X is the number of $5 tickets. Y is the number of $8 tickets. So in rows 5 and 6, we're going to write a system of inequalities. So there's only 2 different types of tickets that you can buy for this dance. You're either going as an individual or you're going as a couple. So combined, all the individuals and all the couples put together cannot be more than 500 people, because the gym can't hold more than 500 people. So the number of $5 tickets plus the number of $8 tickets, all those tickets cannot be more than 500 people. So your first inequality will be X. That's the number of people that bought a ticket, like an individual ticket. They're going by themselves. We're going solo. Plus the number of couples. So that's Y. When you put all the couples and all the individuals together, that cannot be more than 500 people. So that's going to be less than or equal to. So down here in the lower left corner, You can use the Desmos keyboard if you want to, and it has the nice less than or equal to right there for you. 500. Holy cow, that looks like that fills up my entire screen. So that means we need to zoom out a bunch because it's 500. So we got to be able to see 500 on our graph. So just keep hitting that minus sign until you start seeing your line. Okay. All right, nice. Good job. So, yep, good. So we want it to be x plus y is less than or equal to 500. All right. Okay, good. If you need to zoom out, hit the minus button up here in the top corner. Hit it like a bunch of times. So that way you see your line eventually. There you go, good. Okay, so make sure it's x plus y less than or equal to 500. I see almost everybody's got it. X plus y less than or equal to 500. All right, so the second line underneath that one, now we got to talk money. So each individual ticket's $5. So that means you're going to say 5x, okay, plus each couple, their tickets cost $8. So that's plus 8y, okay? Now this is money now, because as soon as you multiply by 5 and you multiply by 8, that's like how much money they're bringing in from all these tickets being sold. So they got to make at least $1,200. So remember when I was like, we were practicing at most, at least, less than, greater than, all that stuff. If we have the words at least, which inequality are you going to pick? Go ahead and type it. I can see it when you type it. Cool. All right, so once again, if you need to, use the little keyboard down here from Desmos, down in the lower left. This is going to be greater than or equal to. At least, they got to make at least $1,200 on this dance. Otherwise, it's not worth it. So you put 1,200. And then you're going to see this cool looking, I really like the blue and the green next to each other. That looks really cool to me. Okay. All right, so good. All right, good. Nice. Yep, you can totally change the colors if you want to. If you don't like blue and green, you can go with anything else. In fact, y'all know I'm quite partial to purple. If you hit the little gear, you can change the colors to whatever you want. So we could do, oh yeah, that's just, to me, that's just heavenly. So purple and blue, you can do whatever you want, okay? You could do orange, red, anything. Okay, so here's the thing. Even though this looks absolutely beautiful with these colors, we're trying to solve this, right? This is a system. This is a system of inequalities. The solutions, we're trying to figure out what would be a good answer for this. And so the solution lies in the area, the region, where these two graphs overlap. It's like this little wedge, kind of triangular looking wedge right here. That's where all the solutions are. And since they're both solid lines, you could include this point down here as well. Now, it's got to be a whole number. We got to pick whole numbers, guys, because you can't sell a third of a ticket. All right, so we'd have to pick something that would be a whole number in here. I think I'll click right. Wonder if that's gonna let me click. Oh, I guess what I have to do, I like zoomed in a whole bunch so I could see better. So you might want to do that also. It doesn't look like it, like I have to actually type the point. So when you go down to line number 8, type parentheses and graph a point that you would choose that would be in the solution. So I zoomed way in so I could see mine better. I'm going to go with this point. Okay, and I'll do a bunch of them so that you can see there's lots and lots of different answers. Okay, so I've graphed 3 of them. Now over here in this section, over on the left-hand side of the y-axis, those are answers too. But for this particular problem, they wouldn't really make sense. Like if this were just an algebra problem on a worksheet, like what you'll do for homework, then it's okay. But for this particular problem, we are talking about people buying tickets for a dance. So I don't want anything over here because these numbers on the left-hand side of the y-axis, they're negative. So that would be like negative tickets being sold. That's kind of like people, I don't know, giving their tickets back to the ticket agent. So that doesn't make sense for this particular problem. We want our answers to be in this positive region over here. And that's because this is a real life example. And so you got to have positive sales. The X coordinate that you choose is how many individual tickets, and the Y coordinate is how many couples tickets. Okay, so that's that one. All righty, let's move on to slide 9. Alrighty, so this is just an opportunity to share your answers from the other slide with the rest of the class. So, because not everybody else could see your answers. I could see your answers on the last slide, but not everybody else could. So help out your classmates and type 2 possibilities, 2 answers from your last slide. And I will do the same thing. If you see somebody else's answer that matches yours, try to put a different one down. So that way everybody in class can see that all different possibilities could still be correct. All right. Nice job. Good. I know it's kind of hard to find ones that are different because sometimes, Emery, you think they should pay for snacks and drinks? Yeah, I think that's a good idea. Then you could make even more money, huh? We don't normally charge for that at dances though. So just so you know, when we do like homecoming and prom, there's all kinds of like drinks and cookies and all kinds of stuff, and you don't have to pay for any of it. So I hope I see you guys someday at like a homecoming dance or a prom, because goodness, this can't go on forever like this. Usually Miss Hoover and I are in charge of all the drinks and all the good stuff, all the appetizers, I guess you could say. Okay, slide 10. Once you're done with that, move to slide 10. And this is our last slide. I'm interested to see what y'all come up with. You need to create your own system so that when the two regions overlap, it includes that little purple point right there. So start graphing anything. You got to start somewhere, right? So y, it's got to be less than or greater than. I don't know. I'm just going to start with the first thing that I think of. There you go, 2x. I need to get that in the purple region. So maybe I need to move. There we go. Okay, nice job, Emery. You got it. Absolutely, you guys. You can use horizontal lines. You can use vertical lines. You can do whatever you want. You just got to get it so that when those two lines overlap, like I got to come up with another line. And they got to overlap so that that purple point is in the region where both the things overlap. So maybe I got to do a less than. Two. Nope, that's not doing it. So maybe I need to do greater than. There you go. There's one possibility. You come up with yours. Nice job, Simon. Very good. You got to get the greater than and the less than in there so it'll shade for you. Oh, just move it down a little bit more, Dana. That would have worked. You just, there you go. Very good. All right, you're really close, Gloria. Maybe move that red one over a little bit more. You guys are doing really well. You're doing diagonal lines and vertical lines and horizontal lines. Good. Albert, be careful if you're going to use dashed lines, you might want to move one of them over a little bit so that your point isn't right on the dashed line. Remember, if it's on the dashed line, it's not a solution. So move that, maybe move that blue line down a little bit. Maria, I would move your blue line up a little bit. There you go, Dana, good. Move it up a little bit more, Maria. Nice, perfect. There you go, good. There you go, Albert. Good, 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 good. Gaspard, you need another line. You're gonna need something like a y greater than or equal to. There you go, good. Just move that blue one down a little bit more. That was good. Just needs to be moved down a little bit more. Gloria, yours, you need to move that red line to the right a little bit more. So that way your point is in the region where they're both shaded. Move your red line to the right a little bit more, Gloria. Alrighty. Okay, so while you're working on that, there you go, good. Gaspard, you got it. That's good. Gloria, you just need to move your red line over to the right a little bit. Good. So while you're working on that, finish that up, and then you can exit out of Desmos. I get to see all your progress, so you don't have to submit this anywhere. And then we will jump into the homework, okay? I'm gonna minimize my screen and get the homework going. You can do homework in Kami if you want to. That way you don't have to worry about having a piece of paper. You are just graphing these systems, so you'll need to open up a fresh new tab of Desmos to do the homework, okay? So you're gonna graph both of these in Desmos and then match your graph to your Desmos screen. And that's it. That's your homework for tonight. I think you have how many problems? Eight problems, I think, unless there's more down here and I just missed it. 8. Oh yeah, there's a couple more. You have 12 problems. That's what you've got. 12? Yes, 12 problems for tonight. Graph them in Desmos. Have a good eye because some of them are dashed lines, some of them are solid lines, and then look for the region where both of the shadings overlap. That's going to be your solution, okay? And that's it for today. I'm going to stop the recording. And if you have any questions, feel free to send me a message.